And today's Yiddish word is plots. And this means to explode or crack or shatter. Okay, and it's used in an expressive sense. In other words, when they said, when the governor announced that there would be no school for the rest of the year and that we'd be doing everything online, I could have plotzed. Okay, that's how you would say it. So, plots. I'm going to start off lesson 8.2.3 with talking about question number 77 from the text. And this is on page 395. The quadratic that they present you, which is this one, y equals x squared minus 3x minus 7. You're supposed to try and factor this first to see if you can get the roots. So I'm going to give you a moment to do that right now. So to get the roots in this case, what you're going to need to do is place this into Desmos. And then look at the roots, and then you'll be able to get it. This is only one way to do it. Desmos is like the nice, easy, tricky way that you could do it. But there is another way that you can still find the roots. And that's what we're going to talk about here. And what I'm going to talk about is something called graphing form. When a quadratic looks like this, we call this graphing form. Remember, there's a bunch of different forms that a quadratic can have. They can have it like this. And if you remember correctly, this was standard form. Well, and then you also had factored form, which is when it looks something like this. When we factor it out. So it's factored form, we have standard form, we have factored form. And there's another way that they can look, and that's graphing form. Or this is also called vertex form. These are synonymous, means that they're the same. Okay? But here, the big advantage of having something in graphing form is that you can see the vertex immediately. And then you can solve for it. So right now, I can look at this and say, I know what the vertex is. The vertex to this is -1, -25. When something is in graphing form, the vertex is right there in front of you. You look inside the parentheses, and this is your x. And you look outside the parentheses, and this is your y for the vertex. But to keep in mind that the x needs to be the opposite. This is your x. This is your y over here. But this x, when you get it, has to be the opposite of what it is in parentheses. I'll give you another example. If it would look like this for some reason, you would say that the vertex was at 2, -17. The opposite of this, and you keep this exactly the same. So I want you to go right now and do question 79. They're going to present you with a few different quadratics. There's going to be this one. And there's going to be this one. You should be able to get the vertex from each of these. It doesn't matter that there's a coefficient outside. We just care what's inside these parentheses and what's added, subtracted at the end. And remember, it's always the opposite of what's in parentheses. This has to do with zero product property. Remember, when you're solving at the end of zero product property, when you have something like this, and you solve it, remember it's the opposite of what's in there. X minus 2 equals 0. X equals 2. Well, that's the same thing that's going on here. You're getting this, and you're getting this. I'll give you a minute to go ahead and get those. Did you get the vertices? Well, I'll use magic to write mine down. And there are your vertices. 2, -5, -4, 3 for both of these quadratics. So I want to go back to this equation. this quadratic. And I want to show you how, yeah, we got the vertex. You should be able to easily see it at this point. -1, -25, which is the advantage of putting things in graphing form, which we'll learn about later, how to make this from a quadratic that's in standard form, excuse me. But from here, you can also get the roots. You can rearrange this into the quadratic standard form that we're all familiar with and go ahead and get the roots. So I'm going to do this right now so that you know how to do it when you see it in the book, especially in question number 80. So you're going to go ahead and x plus 1 squared, well, that's going to be x plus 1 multiplied by x plus 1. You're still going to subtract that 25. Now we multiply this out. We go ahead and we take our usual generic rectangle. We multiply it out. I'm not going to do this whole thing for you. But this is what you should get. We're still going to subtract that 25. Then I'm going to combine. And now we have it in standard form. We'll go ahead and we'll factor this.
Use our generic rectangle. And our diamond. And we'll say, okay, x squared minus 24, multiply that. Put our 2x on the bottom. And this is going to be 6x and negative 4x. This is x, this is x, this is 6, this is negative 4. So we go ahead and we get x plus 6 and x minus 4.
Now we'll go ahead and use zero product property.
Set this to 0, which is the first step of zero product property. We'll go ahead and we'll split this up. One of these, or both of them, 0. So we go x plus 6 equals 0, x minus 4 equals 0. And we go ahead and we subtract. Notice how I show all work. So now we have roots. X equals negative 6 and x equals 4.
So now we have 3 points on this parabola. We have -6, 0, which we get from this answer, this 0. We have 4, 0, which we get from this root. We have the vertex, which was -1, -25. We also have one other thing. If we go back to the original, well, actually to our quadratic here, x squared plus 2x minus 24, the one that was in standard form. Well, if we just cover up the x's, because if x equals 0 in this case, you get -24. That means it's our y-intercept. So 0, -24 is our y-intercept. And this is the whole reason for doing this. We get the vertex when it's in graphing form. We can change it and make it to get our zeros or our roots. And we can go ahead and have our y-intercept, thus having 4 points on the parabola and thus being able to do a really quick sketch of this parabola, which I'll do right now with a snap.
And we can see here that we have the x-intercepts, -6, 0, 4, 0. We have the equation on or next to the line. We have our y-intercept, and we have our vertex. And you see, by having those points, you can make a quick sketch. If you're wondering how I did this point over here, I knew that this point was here, and all parabolas are symmetrical, so I knew there had to be a point over here, because they're mirror images of each other. Watch this
Video, then you can go ahead and do problem number 81. That's on page 396. and let me know how it goes. I'll try and put this one up on the website, or excuse me, on Google Classroom, the moment I put this video up. I'll have them go up at the same time. That way you can show me your answers in Google Classroom. Thank you very much for watching.